Hello everybody. Today we are going to work on some more proofs, continuing in chapter 5 with circles and overlapping triangles. So let's take a look at the first one. What I'd like you to do is actually pause the video and think about a plan and what you might need to do in order to continue the proof for the first one. Please pause the video and then come back to it when you think you have a plan. Okay, so I'm guessing that you have a plan. Let's see what you came up with. It's going to be a little hard because I can't interact with you, but I'll tell you what I came up with. My first thought is that anytime I am given a circle, I'm thinking about radii. And in this circle, I don't actually have any radii. Too bad, because if I did, then I would know I had automatically had congruent segments. And ultimately, if I want to prove that this angle is congruent to this angle, I need something about those two angles. I know that I'm given this and this, but given the circle, I haven't used anything about being given to the circle. So I really, really, really wish I had radii. So I'm going to just draw them in. This is going to seem somewhat random, but I am allowed to do this because I have 2 points, right? I have F and I have O. And how many points determine a line or a ray or a segment? 2. So I'm actually going to do that. I'm actually going to draw in 2 segments. I'm going to draw this one. And I'm going to draw this one. Now, those are both radii of the circle, and radii of the circle are congruent. So not only do I have now congruent segments, but I also have just made triangles, which I can prove triangles are congruent, and if I can prove the triangles are congruent, then I can prove their corresponding parts are congruent. So now I have the ability to do this. These 2 segments that I just drew in are called auxiliary segments. And the way auxiliary works is that 2 points determine a ray or a line or a segment. You choose based on what it is that you drew in. In this case, we drew in segments. So 2 points determine a segment. We have those 2 points in the diagram, so I am allowed to do this. So here's what it's going to look like in a proof. In a proof, I'm going to start with circle O being given and FG congruent to GH, only because I can save myself a step by adding in this. I didn't draw any conclusions directly from that. Now, it's a circle. I'm going to say I'm going to draw OF and OH. And the reason is 2 points determine a segment, because in this case we drew in segments. Okay. Some people do it this way. Just show you. 2 points implies that I have a segment. Either way. Okay, I'll take either one. All right, so now that I have those 2 segments, those were purposeful. I drew those in particular in because OF and OH are radii of circle O. And how do I know that? Right. Assumed from the diagram. So now OF is congruent to OH because radii of a circle are congruent. So here I am. Oh, I see it. GO is congruent to GO. That's reflexive. So now triangle FGO is congruent to triangle HGO by side, side, side. Got my first side in step 1, got my second side in step 4, and my third side in step 5. And finally, what we actually want to prove is that angle FGO is congruent to angle HGO, and that is by corresponding parts of congruent triangles being congruent. So now that looks pretty good. We did need to draw in an auxiliary segment. We needed to draw in 2. And the thing is that you want to be really, really careful, right? Don't just start drawing in auxiliary segments randomly, willy-nilly, you know, like all over the place. You want to hold that back and only do that in extreme cases, all right? So let's be careful to don't overuse aux lines. Okay? All right, let's try another one. All right, so in proof number 1, when we look at this, the first thing is we're trying to figure out what are we proving is congruent? What 2 triangles are we going to prove are congruent? So take a minute to just look at the diagram and see what triangles you see, because there are a number of them. I actually see, in terms of triangle pairs, let's see, I see this one with this one. That's one pair. I see this one and this one. That's another pair. So the first ones I saw were the bow tie, kind of like the bow tie triangles, and then these are what we call overlapping triangles. And I even see a third pair. I see this one and this one. Another set of overlapping triangles. So we have to figure out, based on this information, what 2 triangles we're actually looking at. So let's see. Angle AEF, that's this one, is congruent to angle AFE, this one. And angle CEF is congruent to angle BFE. So, what 2 triangles use those 2 pairs of angles? Kind of looks like we have this triangle. See the blue angles for that? Right? We've got the 2 base angles of that yellow triangle with the blue tick marks. And this triangle it's its pair, right? The overlapping triangle that goes along with the yellow one, but also look at the green angles. Again, those base angles. Right on. Okay, so if we've seen a diagram similar to this before, you could say, okay, why would you think that these 2 triangles are congruent to each other by transformations? And it looks to me like this is a reflection over that, which would be, I'd say, the altitude from D to EF. All right, do you see it? Okay. So what are we doing? We're saying that triangle Let's see, what colors do I want to use? I'll use the blue for the yellow triangle. Call that CFE. And I'll use green for the green triangle, BEF. All right, so I already have these two angle pairs given and written. So now the missing piece to say that these two triangles are congruent. Well, I either need an angle or I need a third side. And I see it. I see the third side. The third side is this shared side. See, they both have that same base. And so that's going to be reflexive. Now be careful in how you name that reflexive side. Remember to watch your correspondence. That's side EF in the blue triangle, or sorry, that's side FE in the blue triangle. And in the green triangle, that's EF. You see it? FE, EF. Right? See the correspondence? Okay. This is reflexive. And the reason is side, side, side. Okay, so we didn't need any auxiliary lines here, but this is one of those other sort of tricky examples that you want to think about, right? It's not about the auxiliary line in this case. In this case, it's about the overlapping triangles. So spotting the overlapping triangles that you're looking at, and also being careful of the correspondence in your reflexive side. Anytime you have overlapping triangles, you're going to have something reflexive, something that they're sharing. They're sharing a side, or they're sharing an angle, an entire angle. All right, so kind of get yourselves ready for that. These are the tips that we're looking at. Okay, I'll just write a note of that. Okay. All right, so let's keep going. Looking at number 2. Oh, see that diagram again? That looks familiar. That looks a lot like the diagram we just had. Yep. Do you see the bow tie triangles? You see these overlapping triangles? See these overlapping triangles? Right? So let's see what we're given. Let's start with that. Let's see, we're given that GT is congruent to GH. And we're given that TS is congruent to HO. And we want to prove that TO is congruent. We want to prove this is congruent to HS, this. Good one. Okay, so both of the things that I looked at for what I'm trying to prove, those are both sides of the lower overlapping triangles, like the ones that we did for the problem just before. Those are also sides of the upper overlapping triangles. So it kind of also goes to then what else do we know? The TS and the HO, those are also sides of the lower triangles. And the GT and the GH, those are sides of the upper triangles. This is going to be a challenge. The key here is this last piece, and that is that if GT and GH are congruent and TS and HO are congruent, then couldn't I add these and get that whole long side congruent? And couldn't I add these and get this long side congruent? Now, do you see the two triangles that we're looking at? Do you see it? It's those upper two triangles. So it can be hard when you first start to look at these, and this is another one of those times where your experience, having seen a number of these, will help. So it's the first time you're seeing these, it's going to be a little challenging when you first look at them. All right. So how are we going to start this? I'm thinking I would start with the givens. And I think I can list them together. Because then the next thing I'm going to do with them is I'm going to add them together and say that, excuse me, GT is congruent to GO. Oh wait, I didn't do that right. It's not GT. Hold on. GS. That makes a difference. And why can we add these together? I just said it. I stole my own thunder. This is the addition property. So right now with my given, I've got one side. With my second step, with the addition property, I have two sides. So if I could get the third side, I'd be all set. But wait, it's the third side that we're trying to prove. So think back to what I said earlier about the overlapping triangles. Overlapping triangles have something in common, something reflexive. They either have a reflexive side or they have a reflexive angle. So look at these two triangles. Do they have a reflexive side? No. Do they have a reflexive angle? Yes. They both share this angle right here. That's angle G. So I'm going to say angle G is congruent to angle G. When I say angle G, there's only one I'm looking at, right? Can't, right? It's not like I could confuse it if I couldn't say angle O, because then I could have multiple. So, all right, here we go. And this is the reflexive property. So now I have it. I actually have these two triangles are congruent. I have triangle GOT congruent to triangle GSH by side angle side. I got my first side in step 1. I got my angle in step 3, and I got my second side in step 2. And so now TO will be congruent to HS because corresponding parts of congruent triangles are congruent. Okay, so watch again. In the previous problem, we had the overlapping triangles above shared a side, but in this case, the overlapping triangles shared an angle. Okay? These are the things you want to look out for with overlapping triangles. All right? Okay, one more and then we're done. All right, we have two circles. We have circle R, we have circle S. And we want to prove that ray RC bisects angle ARB. Okay, well, if we work backwards just a little bit from this, what we're trying to prove, RC bisects ARB, well then that would mean that this angle was congruent to this angle. So I need to prove that those two angles are congruent in order to say that RC bisects angle ARB. So let's see, how could I prove those two angles are congruent? Well, if this is a circle, if R is a circle, these are radii, so those are congruent. But if I'm looking at the two triangles that I have, that's kind of all I know. Are you thinking what I'm thinking? That is that in circle S, we don't have any radii drawn, but if we did, they would be congruent. So instead of looking at these triangles, you might be looking at these triangles. What do you think? We have a plan. Okay. All right, so I'm going to start with the given circle R and circle S. Next thing I'm going to do is I'm going to draw in SA and SB. And why is that? 2 points determine a, what did we draw in? Segments. All right. So next I would say that RA and RB are radii of circle R, and SA and SB are radii of circle S. And that we can assume from the diagram. And now that we know they're radii, we could say that RA is congruent to RB, and SA is congruent to SB. Because radii of a circle are congruent. Being careful, right? We said RA to RB because those are the radii of circle R. SA and SB because those are the radii of circle S. Okay? Great, let's mark some of that on the diagram. So we're looking at the top triangle with the bottom triangle, the whole thing, right? If I highlight that, this, and this, those are my two triangles. They're not exactly what I would call overlapping triangles, but they do share something, right? See, they share a side, RS, so I can use the reflexive. So now these two triangles are congruent. By side, side, side. See, I got that in steps 4, 4, and 5. And so now, remember our plan, we needed to say that angle ARS was congruent to angle BRS because corresponding parts of congruent triangles are congruent. And if these two angles are congruent, then RC must have bisected angle ARB. two congruent angles imply a ray bisected the angle. And that's it. Okay, so a couple things to think about when you're looking at the homework tonight is to think about auxiliary lines or segments or rays. Being careful, don't just start putting them in anywhere. Generally, when we've practiced doing that, it's been on circles, trying to get radii. And also, when you see diagrams with overlapping triangles, to think about a reflexive side or a reflexive angle. Okay, you can go ahead and start your homework. Thanks, and I will see you tomorrow.